Hello everyone. I'm going to be talking about how your app is a giant DDoS botnet and other reasons to manage and monitor your network traffic. So my name's Sanae. For almost a year, I've been working on the core Android team at Yelp. The core Android team is sort of an Android infrastructure team. We work on things like networking, but also the performance, modularization, the testing and build infrastructure, things like that. Before that, I did my PhD related to mobile networking. So mobile networking has been something that's interested me for quite some time. And like I said, I work at Yelp. If you're not familiar with Yelp, Yelp's mission is to connect people with great local businesses. If you've never tried Yelp out, I'd recommend that you go do that. But what this talk is basically about is we can't connect people with great local businesses if the app isn't working very well, if the server is down, or if we're using too much data, or if sort of other problems are coming up. And we wanted to make sure that this could never happen. And to motivate why this is something that you might worry about, I'm going to tell you a story. And I've heard similar stories elsewhere, but this is a story from Yelp. So we have an app, and it talks to a server, as is typical. And normally, if everything is good, the server is happy. But then, so we, over time, Yelp is going into a fairly mature app with a lot of people working on it, and it's not really possible to know what everyone is doing and how what everyone is doing might interact with how everyone else is doing. So you can get, wind up with some unfortunate situations. So once we had someone say, we have these logs that we're sending to the server, but if there are network problems, we're not retrying the logs. We should make sure that we retry the logs if there are network problems, and to do it, maybe a little, more aggressively. Around the same time, some users were reporting this strange problem where they were getting these errors. We didn't know what they were. All we got was a screenshot. Based on the screenshot, it looked like it was probably a 500 series server error, but there seemed to be no corresponding, server error that was happening. So we said, okay, we should have some logging related to that. And this was fine for a little while until our analytics endpoint started returning 500 errors. And so then what would happen is you send a log, and then you get a 500 error back, and you say, that's a 500 error. We should log that 500 error. So then, we send two logs, the original log and the new log. And then we say, oh no, two logs have failed. We better log those. So now we've sent 4 logs, and next, we send 8 logs, and so on and so on. And we've got millions of devices around the world. What we've basically got is a giant botnet. In fact, when this happened, the first thing that happened was somebody said, oh no, it looks like we were being DDoSed by some sort of botnet. So obviously this is something that we don't want to have happen. Fortunately, in this case, the change to how we retried analytics, we had a feature toggle. We had the ability to remotely disable this pretty quickly. So this wasn't a huge disaster, just sort of a medium-sized disaster. But this sort of got us thinking a lot about we sort of take for granted mobile network traffic and what the implications are of having all these devices from all around the world sending so much data. And especially because due to this, we were talking to people from other teams who aren't familiar with mobile traffic. They started being kind of concerned about the implications of mobile traffic. And this is just one of several problems with mobile traffic that's sort of unique to mobile traffic. So another problem is mobile devices often are somewhat data constrained. Like people often have limited data plans. And if you send too much data, they won't want to use your app. And it doesn't necessarily have to be like catastrophically too much data. There could be people there who are not happy with how much data your app is using, who are just silently uninstalling your app, and you have no idea that this is going on. Similarly, battery usage is a concern. I won't talk about this as much during this talk, but the way that you send network traffic can have implications on battery life. So you have to worry about the fact that you're running on more resource-constrained devices than other types of developers have. This is a problem that other types of developers don't necessarily have to think about in the same way. And not to sort of pick on anyone in particular, but this showed up in the news around the time that I was putting together this talk, and this sort of illustrates perfectly what the problem is. There's an app that was consuming way too much data for a while. People were unhappy. We don't want to do this by accident with our app, and probably you wouldn't want to do this by accident either. The other problem is, especially with Android, the Android market is very fragmented. This is from 2014. I couldn't find a more recent graphic, but it is still pretty fragmented. And so as a result, things might seem to work perfectly when you test it. You're probably testing it on a couple of widely used devices, but especially if you have a fairly international audience, for instance, there's probably all sorts of devices out there that are behaving in unexpected ways. And so you have to worry about your app maybe doing things you didn't plan for. Another example of this, what we've personally encountered more is running into problems with people sort of modifying their devices in some way. For instance, installing some sort of custom operating system, or sort of more recently, there's been this trend of people installing these third-party VPNs. So you might be familiar with VPNs in terms of, at work, you connect to an encrypted connection to sort of your work's private network to sort of access resources there. Well, there's this trend of people connecting to sort of private networks in other countries over these encrypted connections that are supposed to give more privacy concerns, but privacy protections. But basically what happens is anyone can put an app on the store and call it a VPN, and then people download it. And we've run into the problem that so these VPNs sometimes install root certificates on your phone and start like man in the middle of the connection. And then if you have protections against that, your app stops working, but then users complain. So this is just sort of one way that users can be doing weird things out there that make your app behave in ways that you don't want. And one thing that makes all of these problems bigger is you can't just necessarily update every device everywhere. Like you can't force users to update. You may have noticed that like usually for every single time you put out an update, there are going to be some devices who decide, for whatever reason, this is going to be the last time that they ever update your app. So any code that you write is potentially out there forever. If it's a bad mistake, your mistakes are there forever. And there may, if you haven't thought about this in advance, there may be nothing you can do. And even like when you do updates take a while to propagate. And also there's sort of more of a cost in terms of user trust if you update too much. Like on the rare occasions that we've had to put out like a second update in an emergency after a first update, we usually get some very rude posts in our Play Store about this. Some people are very upset by this. So you want to avoid doing this. So because of all these factors, we sort of started thinking maybe we need to think about in some sort of systematic way how we're going to deal with mobile traffic. Both to sort of deal with the big problems and sort of the smaller problems that may have sort of some costs over time. So we did sort of consider some other approaches at first. So the first thing that we thought is, so we have this experiment system, which we sort of also use to do, feature toggling, where you have a server, it has a configuration, and the configurations can specify what code runs on the device. So you could basically, wrap a feature in an experiment, and then on the server say, turn this off, and then it syncs with the device, and then the device turns that off. So like, for instance, when we had the DDoS problem, that's how we were able to, stop it from happening. We had a few concerns about this, though. So first of all, experiments are themselves, a somewhat complex system. You have a server that could go down. There's code on the device that could behave in an unexpected way. So it's quite possible that the experiment itself may be the problem you want to protect against. Experiments also have to be set up manually. You have to specify them on the server and on the device. You have to do it correctly. You have to sort of remember to do it at any time that there's anything that you might want to turn off remotely later, which you can't always predict. We tend to, eventually clean up experiments when they don't seem necessary, but it might become necessary to like turn something off later because of an unexpected interaction. And another thing is when we talk about these sort of experiments, we tend to think about them more around features. We do also put infrastructure changes behind experiments, now more so than in the past, but it's something that people may be less likely to think about. So we think, this was sort of a good initial step to preventing these problems, but it doesn't solve all the problems. And it also doesn't solve the problems of sort of generally monitoring what's going on with data on devices. So another question, especially when we were sort of talking about this problem with people at other companies, is this actually a problem that you want to fix? So one caveat is, we're coming at this from the perspective of a company with a fairly large user base, who's is able to dedicate a certain amount of resources to the app stability and app quality. But for instance, if you're kind of a small startup with just a couple developers, or if your sort of user base is much more specialized, then the specific solution that I'm suggesting may not make much sense. The one thing is, so what I'm going to describe, we do plan to open source, which would make the hopefully the cost of setting something like this lower. So when I describe the solution, we basically have one system, but I'm going to break it down into two parts. The part that sort of contains the problem when everything is metaphorically on fire, and then the part that sort of monitors network traffic sort of in a more day-to-day way. This, by the way, my laser pointer isn't, by the way, that's a monitor lizard. It's a pun. So yeah, I'll start by talking about how we shut off bad network traffic. So conceptually, it's a fairly simple idea. We have everything that's going on in the app that might send network traffic, and then between that and the internet, we have a network monitor that intercepts everything and can, based on a remote signal, it can block traffic if necessary. The way that we implemented this is using OKHTP interceptors. If you're not familiar with this, you can basically define some code that will run on every network request and response in a fairly straightforward way. We also had some legacy code that doesn't use OKHTP. We did come up with a way that you could do something similar with this legacy code that's a bit messier. Ultimately, we decided not to do this and instead update our legacy code. But if you don't use OKHTP, in principle, this should be possible. It's just more convenient. So I'll show a bit of code. This is somewhat simplified, so it could all fit on one slide. But sort of the general idea is, we have an interceptor and a network monitor that maintains state about what we're doing. We tell the network monitor about the requests, and based on a signal in the request that I'll explain later, it sort of updates what traffic it's blocking and what it isn't. And then it looks at the request and decides, is it dropping this type of request? If it drops this type of request, it returns a network error. So the network error that it returns has sort of a unique code, so you can treat it separately from other errors, but you don't have to. Whatever kind of normal network error handling that you do should work just fine. So one thing that we wanted to do was we didn't want to add yet another system that developers had to think about when they're building something. We want something that just sort of works without any kind of active involvement. And if we're not dropping the traffic, we just tell the monitor about the response. And it's in Kotlin. The system is built in Kotlin. People seem to like Kotlin, so I thought I would point that out. So I kind of hand-waved how we actually are deciding whether or not to drop traffic. So our first idea was to have a dedicated server that's sort of isolated from the rest of our infrastructure and hopefully thus less likely to go down, that sort of serves a configuration to the network monitor and tells it what to turn off. There were a couple of concerns about this. One, after sort of talking to some of the back-end teams, they said, well, it may not actually be that easy to make it hard for it to go down. And also then you have this complexity in that you have some state. Okay, I'm going to give up on that. But you have some state on the network monitor that you have to sync with the server. You have to make sure that it's updated at the right time, but not have extra overhead. We had some idea for this sort of complex scheme that would involve major back-end modifications, but we decided to scrap that. So instead, so one thing that we were doing throughout this project was we talked to a lot of people from a lot of different teams, because there are a lot of teams who were very interested in this problem. The problem specifically like the not DDoSing side of things. And so talking to what we now call the production engineering teams, what they said was, well, when this happened, the first thing that they did was they started dropping traffic at the CDN. The CDN, if you're not familiar with it, it's basically you have a sort of a proxy server slash cache that may or may not have some sort of DDoS protection that's sort of at the edge of your network, possibly maintained by someone else. But the main thing is it's unlikely to go down in this kind of situation, and you can use it to deal with excessive traffic. So what they suggested is that we return some sort of unique code, like HTTP code, error code, to signal that we want to start dropping traffic. So we settled on a 555 error code because one, that's not a real error code. It's not defined in any RFC. So there shouldn't be anything else in our infrastructure that's sending that. Two, it's very easy to remember. If you get woken up at in the middle of the night and you have to deal with a sudden emergency, it's easy to remember the 555 error code. The other great thing about this is we're not adding any additional infrastructure. Like production engineering doesn't have to then go hunt down the mobile people and figure out what weird infrastructure we've set up. They know how everything works. So yeah, when it gets the code, the network monitor just starts dropping traffic until a timer expires. There's no additional synchronization with the CDN. You just send this one signal. The other thing is, so what we'd actually probably in most cases do is send an endpoint-specific code that says, so the 556 code says, anything that matches this endpoint, start dropping traffic related to this endpoint. But then everything else can just proceed as normal. Hopefully, in most cases, this won't even be noticeable to the user. There's just one little bit of the app that is not working, but everything else is working fine. The server is up, everything's great, and we just have to fix this one problem. So a couple details. So when I mentioned retries, if you do something like this, it's very important to not tell all of the devices in the world to simultaneously stop sending traffic and then in unison, 10 minutes later, start sending traffic again. That would not be great. What you want to do is pick timers randomly so that you restart kind of in a way that the restarts are spread out. And again, this is something that we worked with production engineering to figure out how we should spread it out safely in order to not potentially cause any sort of problems to our servers. Another thing is, so we realized that there were some unlikely but possible scenarios where we would have to worry about things being persistent. So for instance, maybe you have something that's starting up in the background, keeps crashing and restarting, but sending traffic every time. And because it keeps restarting, the state is lost. It doesn't know it's supposed to stop sending traffic. You keep telling it to stop and it keeps starting again. So then we set it up with persistence. We use Realm, but you can use pretty much any standard thing. And this wound up adding a certain amount of extra complexity to this. You have to worry about how you sync state with the database without adding extra overhead. We use Kotlin coroutines. The sort of bigger concern is, so the absolute safest thing to do is to not send any network traffic until the network monitor is fully initialized. But there's probably some little things that you need to do fairly early in your app startup process. And if you block everything on that, you could have some performance overhead. It wasn't a huge performance overhead. I don't remember the numbers, but it was enough that we decided that we probably don't want to do that, and we want to let some network requests happen in parallel with the network monitor starting up. So we're sort of introducing a little bit of risk to improve performance. So that's basically how we deal with sort of the worst case scenario when we're sending too much traffic. So next, I'll talk about the network monitor. So yeah, this is to deal with kind of the subtler problems, like maybe the amount of data that you're sending is gradually creeping up and you don't know that, or you have a few devices that aren't behaving well. So basically, the idea is you get the network monitor to start sending logs to a log server. So the way that we do this, so the first thought is, why not just send a log related to every network request? But that's, a lot of overhead. That's a lot of data. And what we actually care about is sort of trends in the amount of data that's being sent. So what we do instead is we kind of add up the number of requests and the amount of data. So, we have a request. We log the amount of data. It's one request. Another request. We add up the data. Then some time passes. Then we send off the log. So now we kind of have summaries over time of what trends in network usage look like, and we can behave accordingly. We also looked at seeing if we can flag sort of excessive traffic kind of in the outgoing logs to kind of alert on that early. It turns out that it's difficult to when you have like a large number of endpoints, a lot of features whose behavior is changing a lot, and you're experimenting with a lot of different things, as well as users who use the app in very different ways, this is actually very hard to do well. So this turned out to not work out terribly well. Another thing I'll mention is I've been using the word endpoint, but the way this is actually implemented is you have basically a function that takes in a request and spits out a label of some sort. So you can really kind of group the endpoints any way that happens to make sense for you fairly easily. Another thing is, so we aren't actually sending out these logs every 10 minutes. And to explain why, I'm going to go off on a bit of a tangent about how cellular networks work to sort of explain why this is a problem in case people aren't familiar with it. So when a device connects to a cell tower, there's some performance overhead. So if you connect it to the cell tower every time you send something, the network would be noticeably slower. We don't want to do that. However, usually the way that the network is used is you send a whole bunch of requests over a short time period. So when you load a page, there are a lot of objects that are loaded. These days, I don't know the exact numbers, but like on the order of like 100. Similarly, on an app, you're probably not loading just one thing. You're probably loading like a bunch of images and other data. So as an optimization, the connection stays open for a little bit after you send the first request. But that comes at the cost of some network overhead. So this is great for most use cases of the cellular network. The one time that this is a problem is when you are sending logs about things. Because if you send like a small log every 10 minutes, you're waking up the radio a lot to send a very small amount of data. And you can see here, kind of in this very approximate model, you send the logs 10 minutes apart. It consumes way more energy than if you send them back to back. And this is especially the case if you have a lot of users in other countries where maybe they use sort of less advanced cellular networks. Because this has gotten better with like sort of LTE and sort of various sort of US carriers have some optimizations for this. But because of that, we don't want to send logs every 10 minutes. But fortunately, conveniently in our case, there's a very strong relationship between the amount of data the device is sending anyway and the number of logs you want to send. So if you send a whole bunch of data now, but then don't send anything else for a while, you don't really need to find out about that right away because the problem isn't ongoing. The problem has stopped for a while. And so, it might be nice to know earlier, but in most cases, it probably doesn't matter that much. So we can piggyback on the next time the app sends network traffic. Conversely, if you're just continuously sending data, you'll find out pretty quickly. And so in this way, we can send fairly up-to-date logs without much significant overhead. So that is basically how the network monitoring side of things work. So far, we fortunately have not had the opportunity to test out the DDoS protection. But I'll give one example of how this saved us sort of a lot of time and effort, kind of on sort of debugging things locally. So we had intern who joined the company and enrolled in sort of our dog fooding program, our alpha program, right away. Was very enthusiastic. But then 1 month later, it says, "Oh, you have used up tons of data." And so when he came to us, initially we thought, okay, we have to drop everything and deal with this. What if this is happening in the wild? We looked as far as we could tell, nothing was happening in the wild. In fact, it seemed to be only happening for this one unfortunate guy. Nobody else in the company was having this problem either. And we had a hard time debugging it. We tried a lot of different things to figure out what was going on. But this was shortly after I had sort of set up the network monitor internally, and I thought, okay, maybe let's look at the logs to see if that helps. And then it was immediately apparent that there was sort of this periodic kind of background traffic that was consuming a lot of, or it may not have been periodic, but it was in the background. It was consuming a lot of data. We talked to the team responsible. It was kind of like an experimental thing they were doing. It was just being used sort of internally in the company. So then we knew we could safely go ahead with the release. They would just have to solve this particular problem that they had, and then everything would be good. So this wound up sort of saving a lot of time and worry. So currently, we have this as part of our release monitoring process. We have a dashboard that has sort of all sorts of statistics about sort of the current release, and so we can see now if we're consuming significantly more data than in the past. We can deal with this like right away. even if we're just consuming a little bit more data than the past, we can dig into that and find out if it's a problem. We've also set up alerts for, if anything strange is happening with the amount of data we're suddenly sending or the number of requests we're suddenly sending. And as I mentioned, I'm planning to open source this. The plan was to open source it before droidCon. Unfortunately, that has not happened, but it will happen soon. And I'll mention that I've sort of mentioned some specific technologies like OKHCP, but we set this up from the beginning to be open source, and so we set it up so that you should be able to pretty easily sort of just write some code that will interface with whatever technology you're using, and it should be you should be able to integrate it into whatever it is that you are using. So if there's one thing that I want you to take away from this talk, aside from the fact that there will be at some point an open source library that I'd like you to look at, it is the fact that mobile traffic is potentially dangerous. I think people often underestimate that fact and maybe don't think about the implications. I would, if you know like people in whatever the equivalent of sort of production engineering is at your company or operations or whatever it's called, talk to them about how mobile devices work and watch the look of panic spread across their face. Mobile devices sort of are very different from other devices and have much higher risks that people often underestimate. Of course, we're hiring. If this sounds cool, definitely apply here. And we have a whole bunch of engineers from Android around that you can talk to. And you can find Yelp Engineering online. I want to particularly draw attention to two things. One, our engineering blog. Various Android developers often sort of will post things about sort of challenges that we're having or sort of interesting problems that we've dealt with. And on our sort of GitHub page where we have all of our open source stuff, I want to point out that we recently open sourced the Kotlin workshop that we use to train people on Kotlin internally. So if you want to learn Kotlin, this is a good thing to have a look at. And there is time for questions if you have any questions. So my understanding is that on the server side, oh, right, sorry, thank you. So the question is, how do you know which endpoint to disable, basically, if you're just disabling endpoints selectively, how do you know which one is responsible for the problem? So my understanding is that we have like fairly extensive server-side sort of detection of that kind of thing. Yes, so this is not something that my team would be involved in, but there are other teams that sort of would work on kind of instrumenting sort of the server to see where problems are coming from, so that when something's going on, they can isolate the problem. So like how much to spread out the retries? I don't know the exact number, and if I remembered off the top of my head, that might actually be something I'd have to talk to somebody about revealing, because you could probably reverse engineer things about what our network traffic looks like from that number. But yeah, that number will probably differ depending on, it'll be some function of like what the normal load is, what load you expect, what's kind of like the load range that you consider to be a problem versus, just, slightly higher load than usual. So, yeah, so in general, like we've, Kotlin and Java are mostly pretty interoperable, although I've run into like some weird cases with certain types of collections are slightly different between Java and Kotlin in ways that are a bit unexpected. That was sort of the main thing that I ran into. So I think the main difficulty is, first of all, we have to kind of convince ourselves that it's safe to do this. I know a lot of people had concerns about the impact on build times that Kotlin has. So we'd previously put a lot of work into reducing our build times such that the impact on build times of Kotlin no longer was a serious concern. And then, you just have to make sure that you kind of teach people how to use Kotlin, and that people are using Kotlin sort of in an idiomatic way. So we had, the workshop that I talked about. We kind of had a program where essentially, one person who was very knowledgeable about Kotlin would sort of train other people through code reviews, and then they'd become like Kotlin advocates, who could then sort of review Kotlin, and then those people could later become Kotlin advocates. So we had sort of a system for training people. I think those were sort of the two kind of major issues. I guess that is all the questions.